Hi guys, so for video one, what I was going to do is show how we graph these by hand and also how we graph these on the calculator. Alright, this is not simplex method, but it is how we graph these things out. Alright, so 3x1 plus 2x2 less than or equal to 18, we can do that. One of the ways to do that is by getting that into slope-intercept form. So if I label this guy L1, L2, and L3, that's what these correspond to here, then I could get L1 into slope-intercept form, which is basically solving for y, or in this case x sub 2, by subtracting 3x1. We end up with 2x2 is less than or equal to negative 3x1 plus 18. And then if I divide this whole thing by 2, x2 is less than or equal to negative 3 over 2 x1 plus 9. Now, the reason that I like to do it this way is because now I have my y-intercept and I have my slope for that line. That tells me my y-intercept is at 9, so I'm going to go to my y-axis and plot a point at 9. It also tells me that my slope is negative 3 over 2. So I can, if I want to get to the next point on this line, go down 3, right 2. And that should put me here, if we were to look through that. Alright, and I could draw a straight line through there. Okay? Next, I could go to line 2. If I do the same thing a little more quickly, I have x1 plus 2x2 is less than or equal to 10. I could subtract x1, and then I could divide by 2. So I'm going to get x2 is less than or equal to negative, this would be 1 over 2, x1 plus 10 divided by 2 is 5. Alright, so my y-intercept at 5, my slope is negative 1 over 2. My y-intercept here is at 5, I go down 1 to the right 2 to get to my next point on that line. Then I can draw a straight line through there. Alright, last. This one, I'm just going to go ahead and write it out. All we would have to do for line 3 is add the x1 over. I would end up with x2 is less than or equal to x1 plus 2. That means I have a slope of 1, or 1 over 1. Sorry guys, there it is. And I have a y-intercept at 2. Alright, so y-intercept at 2 and slope of up 1 over 1. Those are both positive, so this guy's going to be pointed up. Alright, now that is what these things look like whenever I graph them all out. Now the reason that this is sort of shaded here is because this is my feasible region, alright? And that's because when I look at my slope-intercept form of each of these, I've got less than or equal to, less than or equal to, and less than or equal to on all of those. That means I am below line 1 and line 2 and line 3. So I know I did that in a different order, but I'm below all of them, and that is the only region where I have that. Now, I've already put these into my calculator, but just to show you guys, if I go here, I'm going to hit y equals, alright, and I can, here, I'll just re-enter my first one so that if there's anybody here who has never used the buttons on this calculator to do this. My first one here is negative 3 over 2, x plus 9. Negative 3 divided by 2, x plus 9. Alright, I also have my negative 1/2 x plus 5 and my x plus 2. Now notice all of these are solved for x2, right? x2 is here, x2 is here, and x2 is here. And I want that because that's representative of what we would have if I had two equations that had x and y in them. Alright, so that looks pretty close to what we have right there. Okay, now what you guys do with this whenever I am checking to see or when I'm trying to solve with the graph, as you guys have learned, is I find all the corner points of my region, all right, that is feasible. So that's, all of them are now labeled out. I have 0, 0, 0, 2, 2, 4, 4, 3, and then I've got 6, 0. Okay, if I wanted to solve this problem just by graphing, all right, like you guys have been doing, I would plug each of these corner points into my maximization function. Z equals up here 5x1 plus 4x2, all right, and I could do it that way.